Find a cubic equation with integral coefficient and roots 1 plus I root 3 all over 2 and negative 2. Now before we begin, let's review a little bit about how to solve an equation that we can factor. So we first do it, have our equation, we factor it, we set each factor equal to 0, and we get our solutions. What we're going to do right now is we're going backwards. We want to create the equation that gives us these solutions. When we look at this, find a cubic equation. That means it's going to be degree 3. How many solutions does a degree 3 equation have? From our fundamental theorem of algebra, it has 3 solutions. Now when we look at this and it says it's a cubic equation with integral coefficients, remember integral coefficients, they're integers. That's like negative 3, negative 2, negative 1, 0, 1, 2, 3. It can go in both directions. So it's given us only 2 roots, and we know there are 3. But if we look at our theorem, and it says if we have a polynomial with rational coefficients, and actually this one with the real coefficients because we have a complex number here, then when a plus bi is a root, a minus bi is also a root. Now are integers real numbers? Yes, they are, so we can apply that. This means that x equals 1 plus or minus I root 3 over 2. Remember, your complex numbers always come in pairs, 1 plus that and 1 minus that, assuming our coefficients in the polynomial are real. And we're also given x equals negative 2. What we're basically going to do is undo the solving of this equation. The right side's easy. We can just move the the negative 2 to the other side. We'll have x plus 2 equals 0. That's basically at this stage. On this one's going to be a little bit different. We're going to have to multiply both sides by 2. In essence, what we're going to try to do is get rid of the square root. So what we want to do is isolate that term that has the square root in it. Let's move the 1 to the other side, so we get 2x minus 1 equals plus or minus I root 3. Now that we have the square root isolated, and we can have a coefficient in front, that doesn't matter, let's square both sides. In essence, what we're doing is completing the square for this piece. If we square a positive number, we get a positive. We square a negative number, we get a positive, so that doesn't matter there. Now we can just deal with this other part. We get I squared times 3. I squared is negative 1, so we'll get negative 3. And on the other side, we just multiply this out, 2x minus 1 times 2x minus 1, and we'll get 4x squared minus 4x plus 1. Now we move the negative 3 to the other side, and we'll get 4x squared minus 4x plus 4. Now one thing we notice here that it's possible to do, since the equation just says find a cubic equation, we could take this and divide it by 4, and that would be fine as well. We could use either one of those, it really doesn't matter. This will just keep our numbers a little bit smaller. Now when we have our factors, we multiplied them together to get the original equation. So our factors in this case would be this quadratic, x squared minus x plus 1, and the other one, x plus 2. And it's an equation, so and these are roots of a problem, so it equals 0. Now we just need to multiply it out. You can multiply it out any way you want. I found for some people it helps to put them on different lines, but it really doesn't matter. We have x cubed minus x squared plus x, and then the 2x squared minus 2x plus 2, x cubed plus x squared minus x plus 2 equals 0. And that is our cubic equation. If we were to go through the process to solve this problem, we would end up getting these solutions. of 1 plus or minus I root 3 all over 2, and then negative 2. And that's it.